In this online lecture, we're going to name alkenes. Before we start learning how to name alkenes, I first want to emphasize that you must understand nomenclature of the alkanes before we start learning alkenes. Why? This is because organic nomenclature is all built on one system, and that system we first are introduced into with the alkanes. And as we go on to other functional groups, basically what we're doing is building on the system that we've learned in the alkanes. So if you do not understand alkane nomenclature, you need to go back and try to understand it. Get help from a student, get help from a tutor, come see me, do whatever you need to do to understand alkane nomenclature. And it may be that there's just one little thing you're not understanding. If that's true, then it will be easy to get you to understand it and then be able to build on this for future nomenclature. Well, just as in alkane nomenclature, we have to find the longest chain, we have to do the same in alkene nomenclature. If I look at this compound, you can see that if you want to just find the chain that has the most carbons in it, I would take this and get 6 as my longest chain. The problem is that the functional group is outside of that chain. It's only touching the chain. When I choose the longest chain, I have to choose the longest chain that has the functional group inside of it. So I would have to choose these 5 carbons right here as my longest chain. Notice the double bond is it goes through, the chain goes through the double bond. And that's how you must pick your longest chain. So I would pick 5 as my longest chain. So I would write pentene. Pent for the 5 carbons, and then instead of saying ane, we put ene on the end to indicate the carbon-carbon double bond. But this ene could be here, it could be here. Where is it? Just like we named and numbered substituents, we have to name and number the functional group. So as in alkanes, you can count from either end of the chain, and you pick the lowest number. I can count from this end, 1, 2, 3, 4, or I can count from this end, 1. 1 is a lower number, so I'm going to choose 1 as my numbering system. Now, when we number, we always have one numbering system. I don't choose one numbering system for the functional group and one numbering system for the substituents. I have one numbering system, so now that I have claimed this is number 1 because of the functional group, it stays number 1 regardless of what I'm counting. So this is always number 2, always number 3, always number 4, and always number 5. So now I have to name and number the substituents. If I look over here, I see this is an ethyl group. Where is it? It is on the 1, 2 carbon. So what do? Is I add in front of the 1 that locates the ene, I put the substituents where I name and number them. So if I go ahead and look at these 2 examples down here, this would be 1,2-hexene. This would be 1,2,3-hexene, and then I would number it 2-methyl-hexene. Notice you could actually go 1, 2, 3, but we choose to go this way, 1, 2, 3, because that would give a lower number to the methyl. It's 3 from either end. Okay, so you always number the chain to get the lowest number for the functional group, and then you name and number the substituents just as we did with the alkanes. So let's go through these examples. We already did these 2, and we did this one. Now what we're going to do is look at this. What's the longest chain here? 4. So it's bute. There's 2 enes, so we don't say butene. Now we're going to say butadiene. So when you have 2, you add diene instead of just ene. And if you had 3, you'd say triene. 4, tetraene. And you have to number each one. Notice, this one's on 1, and this one's on 3. The number is always the first carbon that you encounter in the functional group. So this is 1 and never 2. This is 3 and not 4. So it's 1,3-butadiene. And then, of course, there's a methyl on the number 2 carbon. Let's look down here. This is a 6-membered ring, so we say cyclohex. It has an ene in the ring, so it's cyclohexene. This is the number 1 carbon. It must be. In a ring, the functional group always is on the number 1 carbon. So 1, 2. The numbers must go through the double bond. You can't go 1, 2 this direction. They must go through the double bond. So this is 1-methyl cyclohexene. If the methyl was instead right here, I have to count 1, 2 through the double bond, and then that would be 3. If it was over here, I would count 1, 2 through the double bond, and then 4. And if it's here, then it's 1, 2 through the double bond, and then 4. Do you understand what I'm saying? Always go through the double bond when you're counting. Okay, if I look at this ring, I see it's 6 and a ring, so it's cyclohex. Now there's 2 enes, so I'm going to say cyclohexadiene. What else can I say? Well, what number are they on? If I count this one 1, then 2, 3, 4. 1, 4. If I count it the way they did it, 1, 2, then this is 4. It doesn't matter which one you start on, you're still going to get 1, 4 cyclohexadiene. Notice you can say cyclohexa-1,4-diene. Likewise, you could here say, let's see, go up here and say 2-ethyl-pent-1-ene. I could here say instead 2-methyl-buta-1,3-diene. Some people like that, some people don't. It's up to you which one you want to do. You can choose. For me, you can use either way, and I'll consider it to be correct. And basically, IUPAC considers both to be correct too, so either way is accepted in the literature. If I look at this compound, I would see this is cyclopent and then cyclopentene. Now, why is it you don't go 1, 2 to give lower numbers to the methyls? It's because you must go through the double bond. So this is 1, 2, 3, 4, 5. So it's 1,5-dimethyl and then cyclopentene. Sometimes there are substituents that have the carbon-carbon double bond in them. So when they have an ene inside them, they're named as a substituent if they're subordinate to the other chain. Let's look at an example. If I look at this molecule right here, ooh, you can't see here. Okay, if I look at this molecule right here, what do you see? There are 5 in this chain and there are 4 in this chain. So this chain is subordinate to this one. The primary chain, or the longest chain, is this one. And what is that? That's cyclopentene. So now we name this part as a substituent. If I look at the substituent, I would see that is 1, 2, 3, 4. It's shown over here, just like this. 1, 2, 3, 4. Okay, 4 carbons gets bute, but it's not butyl because there's an ene in it. So what do we say is we say butenyl. Okay, now that butenyl is on this number 1 carbon, 1, 2. So there is the number 1 to indicate it's on the number 1 carbon. But we have to locate this ene in the chain. If I look, that double bond could be here, it could be here, or it could be here. We consider the carbon that causes it to be attached to be the number 1 carbon. So if the double bond was here, it would be 1-butenyl. Here, it's 2-butenyl. If it's here, it's 3-butenyl. But because this is 1, 2, where the ene is, we call it 2-butenyl. Notice we put a parenthesis around the substituent whenever we have a number that's on a ring and then the number that's on the substituent. we put a parenthesis here so there's no confusion between the 1 and the 2. Let's look at this right here. This is what we call a methylene group. It's a carbon with 2 hydrogens on it attached by a double bond. So if I look at this, the base chain or the primary chain is this ring right here. So we would say cyclohexene. Where is this as a substituent? That's a substituent. It's subordinate to the rest of this. So where is it as a substituent? 1, 2, 3. So we're going to say 3-methylene cyclohexane because the CH2 double bonded onto a ring we call methylene. If there was no ene here, we would just call it methylene cyclohexane. If I look at this molecule, my primary chain, my longest chain is right here because there's 2 double bonds in there and there's more carbons. So now let's name it. This is going to be cyclohexadiene. And we have to number it 1, 2, 3 cyclohexadiene because if it was over here, if the double bond was here, it'd be 1,4-cyclohexadiene. Now we have to locate the substituent here. This is on the number 2 carbon, and what do we have there? A carbon bound to a carbon with a double bond we call vinyl. So carbon to carbon double bond as a substituent like this, we will call vinyl. It's on the number 2 carbon, so we say 2-vinyl 1,3-cyclohexadiene. Let's name this one. This right here again is 1,3-cyclohexadiene. The substituent, however, is something that we call allyl. And allyl, it really could be called propenyl, which we do. We will call this 1-propenyl. And so if I look at this compound, I'm going to call it 2-allyl. Okay, let's look at this example. We find the longest chain with a double bond. That's hept, 7 carbons. Now, there are 2 ways to number. We can number 1, 2, 3, 4, 5, 6, 7, or we can do 1, 2, 3, 4. This numbering system shown, it would give the lower number to the methyl group, but we always choose to give the lower number to the ene. So we're going to have to number from this end. So here's that same compound. 1, 2, 3, 4, 5, 6, 7. So we're going to say hept. Okay, and you see hept, and it's 1, 2, 3 ene. And then here's the methyl group. It's on the number 5 carbon, so it's 5-methylheptene. Okay, another way to do this is to take this 3 that locates the ene and put it just before the ene. Some people prefer to do that, some people prefer to do it this way. Okay, go ahead and try these compounds, name them, and then restart the lecture to see if you named it correctly. Okay, if we look at this compound, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. That is hexene. Where is the ene on the number 3 carbon? If I look at where is the methyl, if I name it 1, 2, 3, that puts the methyl on the 4 carbon. So we choose this way, 1, 2, 3 methyl, 3 hexene. If I look at this compound, it's cyclopentene. How do I number it? This is number 1, this is number 2, and this is number 3. Why? I have to always go through the double bond, so it's either 1, 2, 3, or it's 1, 2, 3, 4, 5. So I choose the 1, 2, 3, so that's 3-methyl cyclopentene. Try to name this alkene. Alkene. Okay, if I look at this, I will find the longest chain is what? 1, 2, 3, 4, 5, 6, 7. So it will be heptene. Where is the ene on the number 2 carbon? Where is the bromo? 1, 2, 3, 4, 5, 6. So this is 6 bromo, 2 heptene.